the essay for paper 3X, and yeah, I've got a table of medullary thickness of different mammals and their native habitat. So what is a medulla, and what we're talking about here? Well, you've got the kidney, and in there you've got the pelvis, you've got the middle bit, which is our medulla, and then we've got our cortex. And if we were to draw a nephron on here, we'd have the Bowman's capsule outside, and then proximal convoluted tubule, loop of Henle dips down to the medulla, and then we've got the collecting duct going down to the pelvis. So the medulla is the part of the kidney that the loops of Henle dip into, and it's where there's a blood supply, the vasa recta, which is going to take away anything that comes out of the nephron. And in our table we've got 3 animals. You've probably heard of these before in this order, relating to their habitat. Aquatic, lots of water available. Mesic in the middle. Terrestrial means on land. And then kangaroo rat means on land but arid. So xeric or arid or dry, low water availability. And in the table we can see how big this medulla is. Is it small like the beaver, or is it large like the kangaroo? And it's the first sentence says the medullary thickness relates to how big this loop is. So thick medulla, longer loop, and that should give you a clue as to what, how to write about that. And then, using your knowledge of normal functioning of the kidney and the types of nitrogenous waste, discuss how animals have evolved to conserve water. So we're all concerned with conserving water. So parts of this essay, we need a little bit on normal functioning of the kidney. So using your knowledge, that means notes. And types of nitrogenous waste. I'm going to definitely talk about that. And then we're going to talk about conserving water using the information in the table. So our first, I'm not going to write all this. So we've got number 1, we talk about the normal functioning of, well, I can spell kidney. And you could give a brief overview of ultrafiltration, I just draw a nephron here. Not very good nephron. But you've got the glomerulus, afferent and efferent arterioles. So afferent arteriole, efferent arteriole, Bowman's capsule, proximal convoluted tubule, descending loop of Henle, ascending loop of Henle, distal convoluted tubule, and collecting duct. So you could give a brief description of ultrafiltration, and you can talk about selective reabsorption here, because that's to do with water. So proximal convoluted tubule, you could talk about selective reabsorption of water. You could certainly talk about the descending and the ascending loop, so you can have, ions pumped out of the ascending loop, and you've got water coming out of the descending loop, so osmosis of water. So the ascending loop pumping out ions, it's impermeable to water. The descending loop, you've got permeability to water and water coming out by osmosis, because these ions are creating a low water potential in the medulla. So the medulla area is here. So this is the medulla. So you can talk about this normal functioning, and you can need to talk about the collecting duct and its differential permeability to talk about ADH and osmoregulation possibly. And you have small variations in the water conditions. So you're going to give a nice overview, and it's a good chance to pour out all that information as the first part of that essay. Then area number 2 could be the length of the loop of Henle. So take this loop here, and for the three animals, you can talk about the relative length and relate it to their habitat. So relate to their habitat and their kind of water availability. You can relate their habitat to the data that you've got. So relate to thickness of medulla, and essentially that is leading to a lower water potential in the medulla. So longer loop or thicker medulla, longer loop, lower water potential in the medulla, and so we're more likely to remove water from the proximal convoluted tubule, the distal convoluted tubule loop of Henle, and collecting duct. So lower water potential. So you can talk about that. And then finally, area 3, we've got types of nitrogenous waste. And particularly to do with conserving water. So things like production of uric acid, reptiles, insects, birds. And why they do that. So they do that to conserve water. So this conserves water. And you can talk about it's kind of crystalline, low mass, little water needed. The nitrogen is going to be in a kind of solid crystalline form that doesn't need a lot of water, because insects and birds need to stay light, because they fly about, so you can relate that to flight. It's a good chance to use your notes and your knowledge and make sure that you get the information from this table. You can quote this data in part number 2. Nice essay.